Hi there, this is Penelope. This is a short video on how you might find the vertex or the turning point and the axis of symmetry of in particular, a quadratic. Okay, so we've got a quadratic 3x squared plus 6x plus 1, and the vertex is the turning point. In this case, it's the lowest point on the curve. It's really important for engineers to be able to find the minimum or maximum of a function. Now, we can use calculus to find this, but a quick and easy way to do it is to be able to take it off the graph. Now, this one's set up so that you can read it off the graph, but if you can't read it from the graph, then you need some way of doing it. We can use the standard form of a quadratic, so that's y equals ax squared plus bx plus c, and then we can use a formula so that if we've got that, and then the vertex is at the ordered pair hk, then h is equal to negative b over 2a. In this example, h is equal to, now here we've got y equals 3x squared plus 6x plus 1. So h is equal to negative 6 over 2 times 3, which is negative 6 over 6, which is negative 1. Now to find k, we just substitute into y to find it. So we know that x is negative 1, so it would be 3 times negative 1 squared plus 6 times negative 1 plus 1, which is negative 2. So the vertex, and you can see this from the graph, is negative 1, negative 2. Now the axis of symmetry is where x equals h. So h is negative 1, so the axis of symmetry is there. We can do it another way. We can do it a more mathematical way, I suppose. We can rewrite the quadratic as y equals a times x minus h squared plus k, and then again h and k are the coordinates of the vertex. So if we rewrite this one, y equals 3x squared plus 6x plus 1, knowing that we need to have this kind of arrangement here, if we write that as 3x squared plus 6x plus 3, and then we need to subtract off 2 to make it back to what it was, then we've got 3x plus 1 squared minus 2. Now, what we need is that comparison. So, what we've got is that h must be negative 1 to match up there, and then k must be negative 2, which we already knew because we'd done this before, but we can use this version of doing it as well. So again, the axis of symmetry is where x equals h. In this case, it's negative 1. And that's the mirror line for that particular quadratic.